Hi everyone, this is Shannon Williams and Darren Shepard from Rancher. Thanks for joining us today for our online meetup to talk about deploying Docker applications using Rancher and understanding a little bit about compose and service upgrades, service discovery. We've got a lot of stuff to cover today. It looks like we've got a great audience here. So hopefully we'll be able to get through it all quickly and have plenty of time to answer questions. Just by way of introduction, again, my name is Shannon Williams. I'm one of the co-founders here at Rancher, and Darren Shepard is our chief architect. He's on the call. Darren, you want to say hi?
Hi, this is Darren.
All right. So Darren and I have done a number of these webinars. So if you've been on meetups, you've been on and seen what we're doing, hopefully you've come back and brought your questions. Today we're going to be pretty hands-on. We're going to be trying to walk through a lot of how to actually use Rancher, how to use Docker Compose, and helping people kind of understand how to get going from square one to having a real Docker management environment up and running. But before we do all that, I just want to kind of sort of talk a little bit about the way we're going to run today's session, because we've been really effective in the past at having these events be more of a meetup and not an actual webinar. So the meetup idea is that we really don't want to get on here, share our screen, show a whole bunch of slides, and then take a couple questions at the end. We really want to have this feel like an opportunity for you to ask questions, to discuss some of these concepts. Often we have people that jump in and are able to provide some interesting insights about use cases and things they're doing, or anything else. So, as we go through this, you'll see a little in your GoToMeeting bar. You'll see a place to put in questions. If you put in questions and you're comfortable talking about them, you're in a place where you can talk out loud. And maybe just note that you're okay with your line being unmuted, and we can have you ask your question yourself. Otherwise, I'll do my best to repeat your question and not butcher your name if I struggle with sounding it out. But however we get to it, we want to make sure that anyone who's attending can have a voice and can be participating in the conversation. So, given that it's a meetup, we always like to sort of talk about what the rules are for a meetup, and the big part of that is obviously questions are welcome, and tough questions are welcome too. So don't hold back on anything. If you don't get something, or if you feel like something is not being explained very well, or we're glossing over some details that you'd like to drill into, fire away, ask away. We're going to spend a lot of today and most of the time looking at screens. We're going to be demoing. We're going to be showing how to do stuff. It's going to be very hands-on. Hopefully you all received the email we sent out last night talking about how to actually set up your own little Rancher environment that pointed to our Getting Started guide. So if you've set that up and you're going to be following along, with this at home, and you get stuck, shoot us a note. But we'll be trying to go at a pace where we keep everyone engaged. But if you want to follow along, you should certainly be able to. I've got a few slides that I want to cover just to set the tone of what we're doing and sort of explain at a high level the ideas we're trying to cover today, but we're really not going to be talking a lot using slides. Most of the discussion will be over the phone and using demo environments. And then as always, we've got shirts and stuff to give away, so that's half the fun of a meetup. So from an agenda perspective today, we're gonna give a quick little update on things at Rancher. We had kind of a busy week the last week or so we'll talk a little bit about that. Then I'm gonna set some context for how to deploy Docker applications, and what we're working on, how we see sort of the application management space evolving with Docker, and that'll quickly turn into Darren jumping into a demo environment and showing everything from kind of the quickly setting up your first Rancher environment to setting up defining a compose script, deploying an application, configuring things like service discovery and load balancing, and health checks and failover, and really giving you an idea of how to start using this technology to deploy your applications. And that'll eat up the rest of our time as we go. Like I said, we'll take questions. In the very end, we'll talk a little bit about about how to get started with the technology. So I mentioned I just want to talk a little bit about what's going on here at Rancher. We've had a pretty crazy week, especially for a startup. It's always one of the most exciting weeks is when we can announce that we've been funded. So last Tuesday, a week ago today, we announced that that we had been funded, and we got Series A financing from two amazing VC firms, Mayfield and Nexus. And we talked a lot about what we're doing with that, and sort of our focus as we try to go from a from an open source startup to to a team that can deliver technology to power the next generation of cloud infrastructure and container infrastructure. So that was really exciting for us. We also then just yesterday announced that Rancher is now in beta. So for the last 5-6 months, we've been doing a ton of alpha projects around Rancher. People have been trying it and testing it, and we've been adding features at a pretty frantic pace. With the most recent release, we've decided to call that a beta release, and that has a number of implications. For us, it really means we are focusing on things like stability, scale, performance, but also on things making it easier to manage, so upgradability and testing out a lot of fixing a lot of bugs and really polishing the platform. So we feel like we've achieved a certain amount of functionality now that we're really excited about, and we really want to focus on making all that functionality really usable. So over the next however many months, we're going to be in beta with as many people as we can get. So as always, everything we do is open source. So we invite anyone to download the code and play with the beta and file issues on GitHub. We're also running what we call our beta program, which is a invitation to kind of participate in a beta with us. And as it's an application. Anyone can apply to participate. You can find it on our website under info.rancher/beta. And if what the benefits of participating in the beta are really, you have access to all of our engineering team. We help you fix any bugs that you run into or support you as you run the product. We also provide some implementation and configuration support as you're getting stood up. And we have sort of monthly conversations to talk about the product, where it's going, some features that we're working on, as well as get your feedback on features that you think are really critical that aren't there, some things that are maybe there but don't work the way they need to for your type of organization. And so we really hope a lot of people will join. There's also some online training we'll run. So we're really excited to see everyone that wants to participate in the beta program. So that's the big news. And it's for us, I think, as any startup, you really focus a lot in the beginning on building sort of the key features you feel like you want. But in the end, the adoption of any technology is down to how easy it is to use, how well it works, how reliable it is. And so that's a lot of what the beta is about, is making the system work really well for people. One last piece of news: if you are going to be coming to DockerCon by any chance, we will be there. Our whole team is going to be there. It's just up the road from us. We're in Cupertino, and it's in San Francisco. But if you happen to be coming, we'll be there for both the hackathon on Saturday and Sunday, where we've got a bunch of people participating, and we're sponsoring it, as well as the actual conference Monday and Tuesday of next week. We're in booth S5, and we'd love to see you in person. So come by, talk to us about Rancher, what you like, what you don't like, if you're there. All right, so now just kind of switching into the topic we want to cover today. The real excitement around Docker from our perspective has started because the user experience of Docker is so good, and the CLI of Docker is so intuitive that what's so unique about Docker in the cloud computing space is that its adoption has been driven as much by developers as it has been by operations. In fact, I'd say even more so. And in the beginning, Docker was really a tool to run complex environments on your laptops. Kind of an alternative to Vagrant, a next step with this type of technology. But what we're moving to now is really with Compose, with the work that's gone into Kubernetes and Mesos and some of the scheduling technology. We are seeing application management become really a key value of Docker. If you look at Compose and your earlier Fig and what it does in terms of allowing you to define an application and easily reproduce it anywhere, it's an enormous step forward in a space that has been quite difficult to deal with. Cloud application management has been around now for 5 or 6 years, but we've really never seen anything take off broadly and become widely adopted, in part because it's been very difficult to apply it to the broad variety of clouds that are out there. And at the heart of what we're doing at Rancher is we're trying to enable that to happen. We're trying to enable things like Docker Compose to run identically anywhere that you want to run them. And so if you're not familiar with Rancher or deeply familiar with Rancher, Rancher is an open source Docker management platform specifically focused on containers infrastructure. So what we do is really two things. Rancher implements what we call an infrastructure backplane. An infrastructure backplane is a set of container infrastructure functionality that runs anywhere you can run Docker. And that means we implement services like container networking and container storage and load balancing, and we do it against infrastructure that could be a physical server running in your data center. It could be a private cloud deploying virtual machines. It could be your VMware cluster, or it could be any public cloud. And then once that infrastructure is implemented and this new infrastructure backplane for running containers is in place, we hook that into whatever method you use to manage or deploy Docker, whether it's something like the Docker CLI, where you just want to do a Docker run and have your containers come up, or it's Docker Compose and Swarm, where you want to deploy a more complex application, or it's something like Kubernetes if you're using that as sort of an application management framework. So we take and plug all of this functionality into these sort of application definition frameworks and management frameworks to enable a consistent experience for entire teams that want to run Docker and run Docker, for serious applications. So when I say we do an infrastructure backplane, just to give you an idea on what's happening there, what we'll show as we go through the demo today is, Rancher itself runs as a management service. So you run the management container, or you build a cluster and run it as a clustered service somewhere behind the firewall, out in the cloud, wherever it makes sense to your organization. And then you add resources, and those resources can come from anywhere. As long as a machine can run Docker, running a reasonably modern version of Docker, you can run the Rancher agent on it. So run it on a physical machine, or I've got here some clouds, private, public. And once those machines have Rancher's agent running on them, whether you go directly to them and create a container, or you use Rancher to create a container, or Compose to create a container, as those containers come up, Rancher implements a private software-defined network across there. And all of those containers can talk to each other. They get IP addresses. They are able to create an application. And as you need additional sort of infrastructure services, that's what Rancher provides. So things like load balancing or service discovery or health checks are all implemented using containers as this globally consistent experience. So even if you're running in Amazon, you might not use Amazon's EBS service. Instead, Rancher will give you a load balancing service based on HA proxy that spans across any cloud or even your laptop, as long as it's part of a Rancher environment. And then the other stuff we're working on right now, which is really exciting, is storage management for containers. So not just networking, but also how do I start to have blocked devices and take snapshots and backups and start to use get some persistent data management for Docker, which is historically more ephemeral. So that's really what the infrastructure backplane is. It's this set of services, and then that all gets exposed as a user as you start to deploy applications through a bunch of valuable user services. So when I take my Compose template, I can deploy it manually, or I can provision it with Rancher. And either way, Rancher will go out and take those links and establish them across the network. So building network connections between containers. Scale up your services with Rancher. You can define a scale. You can also define something like a health check. So Rancher has a health checking service that allows you to say, monitor this container. If for any reason it doesn't respond positively to my health check, and I get a degraded container, respond to that somehow. So either spin up a new container or route the traffic to the existing containers. And when I'm ready to do something like an upgrade, I'm able to actually clone an entire service. So take service A or service web and clone it, replace it with this new container with a new build, and spin that up. But again, using service discovery and networking, have it so that it can talk to my dependent services, but don't send any traffic over there until I validated it, and then either merge in the traffic slowly or shift over, with always the option of sort of shifting back if something goes wrong. So upgrades, all these things are powered by Rancher using the infrastructure services, so networking and services like health management and service discovery, all are critical to enable this kind of experience. And the big stuff we're working on right now are things like DR. So in the next month we'll be announcing and releasing our snapshotting for containers and services, where you can take an entire service, back it up, and recover it when something happens, wherever it's running. So that's really kind of what we wanted to talk about today, is show you all of this, show you how it works, show you how to deploy an application, do these things like set up container load balancing, deploy a container network, use service discovery to to manage your application, to upgrade it, and things like that. So as we're going through this, though, think about how this might fit into an actual organization. Everything we do with Rancher, we do it in a way that we try to be what we call passively managing. So while Rancher is capable of doing things like provisioning out a bunch of containers and setting them up, we also see that people will use Chef or Puppet or Ansible to do that, or Salt. So we've designed Rancher so that it can detect any changes you're making to the host, whether they're through the CLI or through Docker's API or Compose or Kubernetes, whatever it is that you're using that's deploying your application. We'll see that, and using some of the new cool labeling functionality, you'll be able to tap into Rancher's network or to storage or to the load balancing. So everything works regardless of how you want to use it. You can use Rancher's API and CLI, or just a Rancher's UI, or you can use any of these other services. And so, in addition to that, and sort of plugging into the DevOps channel, we also connect to directory services, because people that deploy Rancher are usually managing teams and registries themselves, like things like Docker and Docker Hub and Key and stuff. So Darren will show a little bit of that as we get going. Okay, so enough slides. I want to jump quickly to the demo. Darren, are you all set up and ready to go through your environment?
Yep. Let me share. You want to make me presenter? Then I will.
Sure. Let me make you a presenter. And while I'm making you the presenter, there were some couple questions that came in while I was talking. One of them was about not getting the email, so I apologize for that. I don't know why you didn't get it. Hopefully other people did. The other one is, it's kind of a question about how do we see the HA proxy working to provide services across multiple hosts. So, HA proxy as a load balancer, does a great job of distributing the load. And I'm just making Darren the presenter here quickly. And so, we leverage that as software for our, native Rancher load balancer. We deploy it as containers, and we allow you to either configure it to deploy traffic to either containers themselves or to a service that's defined by service discovery. So I can send traffic to just web or web 2, or I can deploy it to a specific set of containers that I want to deploy to. So Darren, I've made you the presenter. Do you want to share your screen, and we should be able to get going on the demo? Darren, you got your screen shared?
Oh, sorry, I was on mute there. It is not giving me an option to share the screen.
Maybe I put you the wrong person. Hold on, let me just make you try that. Try now.
I think it's because I'm logged in twice here. Okay, let me start showing this screen. And
yep, I can see it. Great, it's working well.
No, I don't think that one is. Okay, let me.
No, I'm seeing your screen. I'm seeing your GitHub page right now. So it seems like it's up and running.
Just has an extremely long delay.
You're getting a bit of slowness on just the screen share.
Yeah. Let me switch over to this other session because I think it's the fact that I'm logged in twice.
Okay.
Sorry, guys.
No problem. While I'm doing that, there's a question. There's a couple other questions that came in while I was talking. One of them was about Docker Swarm, and the question was, do we support Docker Swarm? So we are working. We support scheduling in Rancher today. So there's scheduling capabilities that are built into Rancher natively that are very similar to Swarm. Right now, we've been working on supporting Swarm. We're going to be supporting Swarm soon, but we're still working through some bugs and issues with supporting Swarm. So both in Swarm and in Rancher, getting that sort of working. But the plan is definitely that the actual plan is that things like scheduling will become pluggable. So depending on your use case or the person that is the actual application you're deploying, you'll pick a scheduler that makes sense. So if you want to use Mesos, you can use that. If you want to use Kubernetes scheduler, you can use that. If you want to write your own scheduler that's very specific to something you're working on, you can do that. So there's a scheduler that comes out of the box with Rancher. There's also obviously Swarm and other schedulers. So those will be options that anyone can pick and choose between as they go. All right, Darren, have you got the environment up and running now? Doesn't look like you're sharing. So if you're having some technical difficulties, I can deploy from my environment. Looks like Darren's having some problems getting his environment up and running. So
okay. Let me.
Darren,
wait. Is it working now?
You're not showing as an organizer anymore. So okay, now I made you the presenter again.
Right. Okay. I think we're good now. Can you see? I just said show my screen. Give it a second. Okay.
I can see it now. You're live. All right. Hopefully we've got it solved.
All right. One day we'll figure out screen sharing. Okay. You should be seeing now. Great. Okay, that's perfect. Okay. So okay. Hopefully this goes well. Sorry for the technical difficulties. I'm doing this on a Windows machine, and I'm not a Windows user at all. Not very comfortable outside the Linux world. So we will. So basically, what we're going to do is just kind of walk through kind of end-to-end the experience. We'll get Rancher up and running. We'll set up GitHub. We'll add some hosts. We'll add some projects, some containers, load balancers. Basically, just trying to go through the whole end-to-end flow to kind of see the whole life cycle. As Shannon had mentioned before, please just ask questions as I'm doing this. It's far more interesting if people ask questions. We have a much better discussion. I'd rather not just demo for 30 minutes straight. Okay, so what we're going to do, you should be seeing a terminal here. We're going to get started off, and we're just going to run Rancher. Very beginning, you have some Linux machine running Docker, and you want to get Rancher up and running. So it's very simple. So basically, it's just a Docker run command. We're going to assign it to port 8080, and then we say Rancher server. Okay. So once we do that, usually the first boot, it's got to kind of do some things, set up a database, and it might take like a minute for the first startup. Let's see, I think on this machine it's relatively fast, so it should come up. So while that's loading, so once that comes up, it's going to be listening on port 8080. So let's give it just a second. Right now, it's actually building the database. So the Rancher is actually built off of a database. Like, highly recommend if you're running this, you're looking to run it in production, you use something like RDS or Classical. But okay, all right, it's up and running now. So it's just that one simple Docker run command. So just Docker run Rancher server, and then once we are up, you should see something just like this. All right, perfect. Okay, so so once you come in here, one of the first things you're probably going to want to do is actually set up access control. Right here on the top, it kind of warns you. So basically, right now we have GitHub integration. We'll be adding LDAP and some other maybe whatever LDAP Active Directory and whatever people might be requesting. But the next one is definitely LDAP. But right now we have GitHub, which works great for a lot of open source projects. And you can even see down here in this box here, we even support GitHub Enterprise. So if you have an on-premise deployment of GitHub. So you just need to follow these instructions here. So the first step here, it says click. Let me go back. I'll show you these instructions. So basically, we're just going to register a new application. We just need this one URL for the application homepage, and then the callback URL. Okay. So we just go in here. We say register a new application. Just call it demo. You just need to put in the homepage URL, and then the authorization callback URL. And then we register the application, and this will end up giving me a client ID here, which we just need to paste in, and a client secret. Paste that one in there. Okay. And then we say authenticate, and this will test out that everything's working. We need to authorize this application, and then if everything works, it should reload, and we will have GitHub running. Okay, so we can see I'm actually signed in as Will Chan here. This is actually Will's computer. But once you have
Darren, can I stop you there for just a quick question before we move on from authentication? Randy Black asked a question about whether this method will also support GitLab auth or private GitHub. So maybe you can talk about either of those.
Not GitLab. So basically, this is GitHub, but it will support GitHub Enterprise. So it will do the if you have GitHub Enterprise deployed on premise. So that's basically the only way that you're going to get kind of something private. It's not on the internet.
Yeah. The next real our expectation, Randy, is that LDAP and AD support will probably cover most of the private use case, behind the firewall use case. So we're kind of prioritizing those two. But if things like GitLab are critical, it'd be great to know that. So certainly, thanks for bringing it up. Okay.
Yeah. Okay. So so once you have GitHub set up, what you can do.
One last question on that. There was someone else. A quick follow-up said, what about Google apps or Google single sign-on? Would we support that or Bitbucket? Someone else asked as authentication method.
Bitbucket is one we've definitely gotten requests for, and I think after, as I mentioned, the next one will be LDAP and Active Directory, and then I think after that we will most likely do Bitbucket. Haven't gotten a lot of requests for Google, to be honest. So one of the things is when we're looking at integrating with another authentication system, is we're looking for ones that can also do like group management, and so you can create a group of users and assign them, and I'll show you some of that in the app. So I don't think Google. I'm not familiar enough, I think, with the authentication that Google provides, that if they have those capabilities.
Cool. All right. Well, thanks. Definitely a number of other people said +1 for Bitbucket, so nice show of hands from the virtual room saying they like the idea of Bitbucket.
Okay. Yeah, Bitbucket should actually be pretty easy. LDAP's the really hard one. So once you have things set up with GitHub integration, basically you can go and create more environments. So basically what an environment is An environment is kind of like a shared account. It owns all the resources. So if you're adding hosts or projects, whatever, it owns the resources. And so if you want to collaborate, between multiple people, basically you'll create like a shared environment. And so when you log in, you always get one environment up here. It says default, and then you can go and create other environments. So I can just go and create a new environment here. We'll call it demo. So I can create a new environment, and then I can go and I can add other. Let's see. I can add other GitHub, users or groups or whatever. So if you just click the drop down, it populates kind of what you're already maybe a member of. And so I'll just add, okay, everyone in Rancher.io, I want them to be a member or an owner. And so then anybody, once I do this, anybody who's a member of Rancher.io can now log in, and they will see this environment up here called demo. Okay, so once we have that set up, then what we're going to do is you want to add some hosts. So before we can deploy anything, deploy any services or whatnot, we really need some hosts. So basically what we have is machine integration. So under the hood, this is actually all Docker machine. And we've just kind of put a nice UI on it. And we'll continue to add more and more providers as more and more providers come to Docker machine. There's really quite a few right now. But what I'm going to demo here is kind of EC2. EC2, we've done quite a bit to kind of make this experience nice. Oops, let me launch.
While you're doing that, Darren, there was a question
Sure.
that came in from Chris Irwin. He just was asking, could a Rancher instance be used by more than one environment? And Chris, the answer to that is yes. When you, as you create environments, you can have any number of environments, each of which will have its own private set of resources, like what Darren's creating here, and you can invite different teams of people to each one. You can also give users accounts where they can create their own environments, invite people to that. So it's really anyone who's got a user account can create environments and invite people to participate. There was another question that Richard Silver asked, and it's sort of along the same ones, and I'll let you answer this one, Darren. He was asking if there were any plans to allow the same host to be used across environments with separate container namespace, like labeling. So, one host that is shared in environment A and environment B, and both can provision to it, but somehow keep those containers isolated. Good question. Richard, go ahead, Darren.
I don't know if I fully understand the question. So the container, so there's two aspects of that, because one is right now an environment owns both the hosts and the projects, which are like the services and containers that are being deployed to the hosts. So that's the way the app is structured right now. We definitely see that over time that will probably change, because we're getting this request that people want to set up an environment that owns the hosts and then a separate environment where they have the projects, so that there's kind of an abstraction between the underlying resources. Now there's some bigger questions about security on how that works, because Docker right now is really not the best for security in a multi-tenant environment. That if you have one host and you have multiple users you don't really trust deploying to the same infrastructure, that can cause some problems. But you can definitely, we have the ability, and we'll show this later in the demo, to do scheduling based on tags. So you can say, like, this application deployed to these hosts because they have this tag. But right now everything is actually in one environment. But I think over time we will separate that out, so you can get kind of one team to manage infrastructure and one team to manage applications.
Great. And there was another question that you may be about to show this. So I'll let you show it as you were going to go. But Guangzhao was asking, in addition to like provisioning EC2 like you're using here, how do they add other cloud resources from private clouds or public clouds? Is that the custom, was his question? So,
yeah, so that's this custom tab right over here, and I'll show that in just a second. I just don't want to click away and lose my keys that is copied and pasted in here.
Go for it.
So I'll show that in just a second. So I'm going to show you kind of our EC2. So this is, again, it's all backed by Docker machine. One of the things that we've done with Rancher in general is we haven't programmed anything specific to any cloud. It actually runs across any cloud, bare metal. basically any infrastructure. You can even run it on your laptop. We have nothing that's specific to a cloud. The only thing that's kind of cloud specific is this add machine or add host. But again, this is leveraging Docker machines. So our kind of our perspective is so we've made the EC2. If you're a user of EC2, can be kind of complicated to get things set up. So we made this really easy. You just put in your access key and secret key, and don't get any great ideas. This key will be deleted. So we just go to the next one here. So click next. We automatically look up, what are the availability zones and what subnets and whatnot do you have in each one. So I can just say I want to deploy a new instance in that subnet. Then we're going to select the security group. So you can use, if you say use the Rancher machine group, then we'll just set it up, or you can use a custom one, maybe one you've already configured. So we've already listed all the machines, all the security groups you have there. And there's a couple ports that we need for communication. So this is how we do some of the stats. Actually, this requirement has gone away in the latest beta. But this is how we basically do our overlay networking. We need these ports open. But I'm just going to click and say use the standard one. So then once we get here, we can say, okay, well, I want 3 of these, and you can give it some name. So we'll just call it like demo, and they'll name it demo 1 to 3. Select the instance type. We'll go with some T2 mediums, the root size, a lot of these other options here. You can just leave this blank. It'll just put in the default AMI, and then click create. And then so this will go out and start creating these machines. So in reality, this will take about 5 minutes or so. It's got to deploy through Amazon, and then it will do install Docker, through Docker machines. So it does take a little bit for these machines to come up. So I've kind of cheated, and I have in another environment already set up here that has some hosts. So we'll probably, for the rest of the demo, I'll be using this other environment. But going back here, to answer the question about adding custom hosts is, this is a great way, like these clicking, this add host, this is a great way to get up and running really quickly. But honestly, the most common way that we see people adding hosts is just through this custom option. And basically what it is you just need to copy this big long Docker run command, and then just paste that anywhere, and then it will add in the host. So basically, as long as this host can, as long as this host has access to this URL here, then it should register fine. And then the only other requirement is every other node that you have registered with Rancher, they need to be able to talk to each other so that the overlay networking can work. We have this option here to add labels. You can add labels on create. So, if I just say foo bar, you can see it just actually changes the command down here to add in some labels. And so these labels are really important if you want to do some neat things with like auto-scaling, auto-scaling instances through like Amazon, and when they come up, automatically have containers deployed to them and things like that. So that's the custom option here. Okay, so I'm going to switch.
That came in before you jump away from there. A couple questions that came in, Darren. The first one was a question about what's actually being provisioned. So does this provision a Rancher OS host or a TinyCore Docker host, or does it provision whatever you want?
Yeah, and so at Rancher Labs we have 2 products. We have Rancher and Rancher OS, and those 2 products are not at all like coupled to each other. One does not require the other. So what we're talking about here is Rancher, which is just our Docker management. And so what we're provisioning is actually just the Rancher agent onto any Docker compatible host. So basically anything that runs Docker 1.6 well should work. To be honest, Ubuntu and CentOS/Red Hat are the most tested. But we've definitely seen people running in Fedora, Gentoo, Debian, other various random distributions, Rancher OS, of course. So there's, basically we support anything that's, can run Docker 1.6, but all that's being provisioned here is just the Rancher agent.
Then another question, Darren, was whether we supported cloud-config as Jeff says, Jeff Destine, I hope I said that right. He hates tedious processes. So, do we support Cloud Config?
Well, I mean, Cloud Config, that's a probably a question for Rancher OS, and Rancher OS does support Cloud Config. So if you have some, we support a subset of Cloud Config, which is very similar to the subset that Core OS supports. But if you're, for the context of Rancher, we're actually kind of at a higher level than that, than Cloud Config. So basically, if you want to provision a host and have it added to Rancher, then you can just pretty much put this command into your Cloud Config to run.
Last question about just adding hosts, I think, or maybe not, was from Thomas Atree, and he asked if the custom add host option could be automated with OpenStack. So I think, is there an OpenStack machine driver? Because just to be clear, these, other than the custom option here, all of the options at the top, the rack space or the packet option, these are all coming from Docker Machine. And Docker Machine is an open source project where cloud providers write basically drivers, little plugins that allow you to provision and deprovision hosts. It's really useful for us because we love that the cloud providers themselves are doing all the work to integrate, and they're sort of writing it as ideal as they can. So the great news is, yes, there's already OpenStack and CloudStack drivers out there. There's VMware drivers out there if you want to provision on vCenter. There's Google and Azure drivers. So we support all of them, so you can use any of them from our API. From a UI perspective, we've added a handful, and I think there's a handful more coming over the next couple of weeks. And our plan is to make it so that anything that has a Docker driver, you can use from the UI as well. So hopefully that answers your question.
Yeah, and I'm not, I was just going to look really quickly at our API here and see if I can actually show that projects. What is it? Machines. What I'm showing you here is actually our API. We do have a full API for Rancher, and it actually has this nice little interface on it that you can click around. Right. So right now, from the API perspective, I can show you what we have: Amazon, Azure, DigitalOcean, Exascale, OpenStack, Exascale, Packet, Rackspace, SoftLayer, VirtualBox, which actually makes not a lot of sense because that's going to deploy on your local machine, and then vCloud, Air. So basically, what we do is we take whatever the latest release of machine. And then we kind of auto-generate the API for Rancher. So, we basically support them all. But these are just the ones that we have kind of like an optimized UI experience for. And we'll probably add another button here for kind of generic, where you can see, where you'll be able to kind of generically do everything that we supported from the API, but it just won't be as like nicely optimized. Like these ones, we really, we made them kind of specific to the provider. So yeah.
Great. So let's get moving. We spent a lot of time on adding hosts. If anyone has any other questions, I'll try to answer them offline. But thanks for all the great questions about adding resources.
Yeah. Okay. So yeah, let's move along here. Oops, that's not the one. Okay. So what I'm going to do is I'm going to switch back to, this is an environment where I already have some hosts, and we want to start talking about adding containers. So at kind of a low level, you can just go, like these are my hosts that I already have. Each one of these boxes represents a server, and so I have these are actual Google instances. This is I'm running on Google Cloud. You can actually see, I've got some stats about it. I can see I'm running Docker 162 and how much memory you have, so just some basic things about it. So if you want to, you can just go and deploy containers directly. This basically gives you all the options, the same thing as Docker Run. But we have this other way of deploying things, which is called services. And this is, so basically what a service is a service is just a collection of containers. So you kind of start with a template of this is how how I want to launch a container, and then you can say I want like 5 of these. And then we go and we'll make sure that there's 5 of those running. So if we want to go, so we can just spin up a web server here. So we'll do Nginx. And we can expose on port 80, like that. Okay, so once I've done that, created that, I think it's probably going to pull the image. Let's see. Oh no, is that already deployed? Networking. Okay, so the very first deployment, see how it says networking? Let me go back to the infrastructure tab. You'll actually going on here. As you can see, that our very first deployment is deploying a network agent. So the very first one will actually take a little bit of time. Let me just kind of pre-cache these other machines, so the other ones will go a little faster.
While you're doing that, Darren, Alex just asked a question about whether you could import a service from an existing Docker Compose YAML file.
Absolutely, absolutely, and I'll show that in just a second. That's actually, so we're going to be clicking around in the UI for a little bit, but honestly, I'm a lot faster from the command line, and I'll show you how the command line works. And the command line is basically all built around Docker Compose. So once we have, so you can see we spun up this network agent. These other ones are still starting up. They're pulling those. But so you can see, okay, we've launched this web server. If I go and I click on it, it's actually running on this host. If everything worked right, I should be able to hit that and see. Okay, so I got an Nginx web server running. So now, as I was saying, what a service is it's just basically one or more containers. So I can go to this service here, and I can say, okay, well, I actually want 3 of these. So now this is going to go and deploy three of these services. So if I go back here, you can see it actually says degraded. So what degraded means is you've asked for 3, and there actually isn't 3 yet. Oops. Oh, sorry, it only went to 2. Let me click one more time, so it does 3. So you can see it's actually gone and it's spun up another one. So I have Web 1, Web 2, Web 3. If I go back to my, let me just open the infrastructure view in another tab so I can just easily switch back and forth. So you can look and see, okay, so this container here is actually my Web 2. It's a little hard to see the names here. Let me go to the container view. You can see, okay, Web 1, Web 2, Web 3 are deployed. So those 3 are running on separate hosts. So there's 1, 2, 3. And so I wanted to actually point out, this is actually some of our our scheduling capabilities, is that we look at port conflicts, and the reason why these got perfectly balanced across these hosts is actually because they're exposing a public port, and so if they were to land on the same host, then they would conflict. So we perfectly spread those across. But we actually have quite a bit more complex scheduling. So if I go and I add another service here, so if I go into the advanced options and we go down to scheduling, you can say, okay, automatically pick hosts for each running containers based on these rules. And so these rules get kind of a little bit complex. We've tried to do our best to make this easy to digest, but you can basically say we want it to run on a host that must, should not, or must not. Basically, what that means is must mean it's a hard constraint. Like this must not run on something that has, like if you're doing anti-affinity where you don't want this to run on a host that has this other service and you want a hard constraint, then you say must. You can say should, which is a soft constraint, which means we'll do our best, but if we can't find a host, it might end up on the same host. So we'll start with, you say should, and we have different criteria here. You can do it based off of a host label. You can do it based off of a container. So you can say, don't deploy where, deploy where this other container is with this label, or don't deploy. You can do it based off of a service name. So here I can say this is basically going to do an affinity rule saying it has to deploy to a service, where a host where it has this service. And the last one is basically with a container name. So it's really flexible. honestly might be confusing sometimes, but you can do quite a bit with the various different rules of how you want to schedule these things. Okay. So let me switch to the command line from this point forward. So as someone asked, can we do, import an existing compose template? So in this corner, up in this corner here, we have Rancher Compose CLI, and you can see we can download. I'll download it for Windows since I'm on Windows here. It is not commonly downloaded and could be. Oh, that's great.
We'll have to change that, I hope.
We hope it's commonly downloaded. I don't know if it's because it's from like this local URL or something. So basically, you can see here. Okay, well that's for Windows. I'm going to switch over to Linux because, as I mentioned before, I'm not very comfortable on Windows. But I have a terminal open here. So if I go over.
Just while you're doing that, a couple questions that came up during that, and you can get yourself set up. There was a question about the networking. So does Rancher support IPv6 networks?
So it does no. So it does not currently. So our overlay network will run over. Basically, our overlay network is IPv4, and so there's. I'm trying to think that it's possible you can have an IPv6 fabric, but our overlay network is still going to be IPv4. But basically, IPv6 is still kind of in the roadmap.
Then another
now
question,
that Docker.
Oh, sorry.
I was going to say Docker added support, I think, in 1.6 for IPv6, so that makes it a lot easier for us to support it.
There was another question which we should have probably mentioned earlier from Michael Klatsky, and he was just asking which version of Rancher server are we running for this demo because it looks a little bit different and new. This is the beta. So this is the brand new beta. We just shipped it. So you can see there what we're running. It's version 0.24.
Yeah. So this is the beta. So if you run, if you do a Docker pull Rancher server to get the latest one, this is the version that you're gonna get. So yeah,
this is the first version that we're really that's available as beta that we're testing upgrades and things like that on. So if you've already installed a version in the past, and we would highly recommend you reinstall and set up a new environment starting with 24. This is beginning with the beta. If you stay in tune and you kind of keep upgrading, you should be able to stay current without any real hassle. So, good question. Another question that came in, William Kennedy asked whether local Docker images or custom or private registries, I would guess, are supported. So do you want to just show real quickly from the UI how to add a private registry?
Yeah. I mean, so basically you can add in private registries. So basically, to be honest, when you go and you deploy a service or a container or whatever, you just put in whatever, you can say Quay.io, CoreOS, etcd, something like that. So that will pull from Quay.io, or if you had some custom one, which it's at some weird IP or whatever, then that will work. So basically, whatever you would put into the Docker run, you can put in here, and so that works with whatever registry you have set up. So the one thing that we manage on top of that to make this a little easier is basically the credentials. And so when you're adding a registry here, you're really registering credentials. So we've made it easy for Docker Hub and Quay, since those are kind of more popular ones. But then there's also custom. So basically any address that you put in there. So we'll manage the credentials such that when it does the pull, we'll push down the credentials and use them at that time.
Another question was back to the networking a bit, and I think there's two questions that sort of touch on the same thing. So I'll try and cover them both in this. So Signoff had asked, these new containers we just deployed, Web 1, Web 2, Web 3, they've all got IP addresses. Are those IPs of the containers assigned by Docker or by Rancher?
Right. So when we look at this, these are all Rancher assigned IPs. So what actually happens right now, like to get into a little bit of the technical details, is when a container comes up, we assign a IP, or Docker assigns an IP from like the normal like 172 subnet, and then we also assign an IP, which is from the 1042 subnet, which is managed by us. And so what we're showing here is actually the Rancher managed IPs. In Docker 1.7, there's a huge amount of work has been put into networking. They've revamped the internals of networking, and it basically means in Docker 1.8 we're going to see some great networking features to make this even more seamless, such that the Docker assigned IP, Rancher assigned IP, is actually the same thing. We'll be integrating in, kind of further into Docker, which is really, really exciting.
And then another question Richard asked was just, when we give something a container name, like these default web apps that you've been creating or Ubuntu, those container names, do they refer to, is that like a uniquely, like a UUID specifically created by us, or does it refer to the image name, or does the user give it a name? Like, how do you name the container? So I see 2 Ubuntu containers here. What's the name of it related to?
Right. So right now the name is basically just the name that you'll see in Rancher. Like if you go and you log into the host, you will see a UUID. So we're trying to make that such that the name in Rancher ends up being the name on the container, but that gets a little tricky when you're managing things like across servers and you're scaling things, because Docker has this uniqueness constraint on names, so it gets kind of tricky to do that properly. So the name that you see here of the container is really just the name in Rancher. What you'll see on the host.
So that's tracked by the Rancher database. Rancher data, when we understand that name, and it's related to the UUID that obviously Docker uses as well. So we keep that relationship. There was last question on this one that had, well, sorry, Richard asked a kind of a follow-up, so let me see if I can address that. So his question was in reference to the must not and must go on a host with container name rule. So when you get down to the, when you say that like this container must go on a host, is that related to the name of the container or the UUID or the image name? And I believe in this case, Richard, the answer is it's the image name. So it's when I set up that service. Go ahead.
It was going to be based off of, well, so it depends on the rule there. So let me go back to the scheduling rules here. So because there's different options. You can say a container with a label or a container with a name, and the name is going to be the name that we've assigned in Rancher, not the name of the not the one that you'll see actually in the Docker run command. To be honest, the most flexible is going to be the labeling. Because that one you can put any arbitrary key value pairs and match.
Great. Excellent. Okay, on you go. Sorry for all the questions, but that's good.
Yeah, so I just wanted to show a little bit so people understand a little more. So if I've gone back to this first environment I set up here, but if I go and I deploy a container, so as we said, like Ubuntu, so if I go and I start this Ubuntu container here, if I go to the, it's got to wait for, what is this doing? Okay, yeah. So if I go and I say Docker PS, you can see, can make this bigger. Oops. Yep, it's not big enough. But basically, it's this container up here, and you'll see the name is actually a UUID. And this UUID actually is the same as the UUID of the container in Rancher. Okay. Okay, so let's go back. So I wanted to show you, so I deployed this service here. I can actually say view configuration, and this will give me a Docker Compose for this, and this will give me a Rancher Compose. What Rancher Compose is basically deployment-specific configuration. So things like scale, if you want this service to actually be based off of an external IP, and these are some things hopefully we'll have some time and I can show. So let's go through actually using the Rancher Compose command line tool. So the Rancher Compose is basically we've tried to make it as close as possible, perfectly compatible with Docker Compose. We've really tried hard to make this match, just because of some like kind of little technical limitations, we can't use Docker Compose directly. Hopefully that will change over time, but right now the experience should be very, very familiar. The syntax and everything, we have not changed the syntax of the compose file or anything. So as I mentioned, you can if you have the UI running, you can download it just directly from the UI. But in order to use this, we're going to have to set up an API key. So we're going to go and we're going to add an API key. And once I have that API key, I need to set some environment. Like if I run Rancher Compose here, you can see it will ask you, you can set up URL, access key, secret key, or you can just set them to some environment variables. So we're just going to go with the environment variables right now. So Rancher URL is going to be this. So just put the URL import, and then we've got the access key here, and then export Rancher access key, and then the last one is going to be the secret key. Let me just copy that. Okay. All right. So once we do that, so basically. Let me go back, and we will go back to our services view, and you can actually just say export config, and that will give you a zip. I'm just going to copy and paste. So let me just copy that here, and we'll just call it docker compose.yaml, and hopefully this paste. Oh, the formatting's a little messed up. Let me just fix that. Oops. Sorry guys. Okay, so let me just make this really simple. So basically, I just kind of delete some of the lines to make it a little smaller. So we can just see, so we have a web. It's listening on these ports. I'm actually going to just make it so it listens on, like we don't expose it publicly, because as I mentioned before, if I go and spin up this again, it'll get a conflict because the public ports are already exposed on those hosts. But cannot open file for writing. That's a little, okay. Sorry about that. Show recursion. Okay, so I'm just going to type that because I know exactly what it is. Ports. Nginx. Okay, so if I just go and I say Rancher Compose, everything works fine. Let me go back to this view so you can kind of see this working. I'll collapse this one. The way Docker Compose works is it has a project name, which aligns with our projects, and it takes it as basically the current directory. So when I spin this up, you'll actually see it should be, it'll be called bin because my current directory is bin. But you can change that. So you can see when I say, compose up, so basically it went and created a new project, and then it created this web server here. Right now it is tailing the logs, but there are no logs. I can show the logs in just a second. Let's actually just delete that here. One thing that's different, very different about our Rancher Compose than Docker Compose is that we're very specific about deleting things. The way Docker Compose works today is like when you say up and then you hit Control-C, it just deletes or it stops everything. We don't do that. We keep it running because we're very oriented towards production deployments. So some of the behavior is slightly different in that we're a little bit more explicit about deleting things. Like so specifically like the RM command, you have to add -- force if you wanted to delete everything. So you can see, so that actually just went and deleted the web service. If I go and let me delete this other project just so I don't get any conflicts on the ports. Okay. So I wanted to actually expose the ports so you can see like the live tailing of the logs. So all I did there in that Docker Compose was I just exposed the port. So I just want to push it out to port 80. And we'll just say up again. Oops, typo there. So we have that up and running. So once this guy's up, we should be able to go to the host IP, copy that, paste it. Okay, so we got Nginx running. Yeah, so as I go and I hit this, refresh, we get the logs here, I think, because this is Windows terminals, maybe something's wrong with the new lines. But you can see the logs are coming in like that. Each one's a new line, but I think I got something messed up with the formatting. Okay, so let's go through just more of the life cycle of the application. So I just went and I spun up
just a couple questions that came in that are on there.
Sure.
One is a question, two questions from Alex Kirkin. Alex is asking, after you run that Rancher Compose up, will the service be persisted, and can he stop and start it again in the future?
Yes. So you can do that specifically. So when I said up here, okay, so let's go back. So it's going to creating my service here. Oops. Oh crap, that's the wrong button. Let me load that back up so I can actually show you. Oops, why is it on projects? There we go, projects. Okay, so I'm running that, and I did not put the -D, which means it's kind of running in the foreground. But when I hit Control-C, the project doesn't go away. You can see it in the background there. But then I can go and say stop web, and so you see then it went and that stopped. And then I can say start web, and then it will go and it will start it. And then let me hit Control-C. And then additionally, you can scale it too. So I can say scale web 3. So that will then scale it up to 3 servers, the 3 of them. Okay,
so using this, just on that then, does Rancher also, if you're using it in this way, can it deploy something more complex, multiple services,
yes,
a more complex sort of compose environment?
Yeah, and we can go with let's see, Docker, WordPress. Let me see if I can find the
There it is, the fourth one down.
Yep, here. No, that's not the one. Oh shoot, I had it a second ago. It's on the other one. There's a nice I think it's this one. Okay, yeah, let's just go with this. Like, here's a WordPress, right? Everyone knows this one. Okay. And let me make another directory here. So what we can do, Docker compose YAML, and then, oops, I didn't actually change it to my directory. And then paste on. Oh, is that paste? There we go. There we go. Okay, so this is your kind of standard MySQL. So this should work. So let me do a Docker up on, or Docker Rancher Compose up on this one, up on, we're in the right directory and everything. Okay, so basically, so what that's done is it's creating this WordPress. So the very first thing is it's going to run the database. If I click on that container, you can see I think it's probably pulling. Yeah, it's pulling the image right now. Now it's starting up. Let me go back. And then it's starting. So you can see this WordPress image is actually linked to database, which is running across. Now, oh, that's also polling right now. Just give it a second. But let me show you a different view we have here. We can show like kind of the graph of services. Loading. Oh, there we go. Okay, so basically, so this is just a very basic your WordPress example. If this worked, let me click and run the. Oh, what port did we expose it on? Oh, it's on port 8080. Sorry about that. 8080. Right. Okay. So we got WordPress up and running, and now if we go and we look at the hosts, we should be able to see that these most likely got deployed across different servers. So let's see, WordPress. Yeah. Okay. So these are actually running across 2 different servers. So it deployed that WordPress app linked to each other, running across 2 servers on our private overlay networking. So that's just a little simpler application, but let's make it a little bit more fun. Let's do this. So Docker Compose. So now the thing is, this is just one instance of WordPress, but what I instead can do is, maybe I want to scale up WordPress. So I want like 3 of these. So now we get into our load balancer. So you can go in here and you say, okay, add a balancer service. You can do this from the UI. I kind of recommend do it once from the UI first because you can see all the options. So you can basically say, okay, I want a load balancer. I want to load balance the WordPress tier. I want it to run on the public port. We'll do 81 right now, and then it needs to go to the private port. Let me just make sure I picked the right. Yeah. So it needs to go to the private port of 80, which is the private port of the WordPress instance. And then you can also add some health checks if you want it to do like index.html. You have some sticky rules or whatnot. And so basically you can just go create this load balancer.
And what's happening in the background, Darren, there is, you're creating an HA proxy container, correct? That's what's actually being deployed. And you can deploy that on, does that get deployed on a single server? Can it be deployed on multiple servers? How does that work?
Yeah, so it can be deployed. So right now, if I just go and I launch this, it's going to deploy a container on a single server. But then you can go. I can't do it one. Okay. Oops. Shoot. I clicked the wrong button there. Let me go back. Collapse that one. So I can go and here and I can say scale load balancer. So I can have like 2 of these. So I'll run the load balancer across 2 hosts. And when you set up the load balancer, the same, let me try it. Oops. Man, I keep clicking all the wrong things. So when I add a load balancer service, oh, you know what? We don't have it in the UI. You can do it from the Compose right now. We'll add it to the UI, but you can put the same scheduling rules. You can put the same scheduling rules on the load balancer that you can on the containers. So you can say, I only want to deploy these HA proxy containers on these hosts. So when you scale up your load balancer, you can pick which hosts it goes to.
Awesome. One question that came in from Michael Klatsky about this was, since the load balancer is HA proxy, is there SSL termination and or authentication configuration available now or in the future?
Yeah, so we're right now working on the SSL termination. So basically the two bigger features that we're working on right now for the load balancer is host name based routing, and then the other is SSL termination. So you'll be able to configure the load balancer and do upload an SSL certificate.
Cool. And then just to really quickly, guys, I know we're about an hour and 15 minutes into the meetup. We are recording all of this, so if you need to run, we're going to post a recording of what we've done today. So don't feel bad if you need to leave while we're still in the middle, but we're going to stick around and answer questions as always as we go. Roman had a question. He was asking, is there a doc or are there docs for what can go into the Compose file, like the load balancer feature host pinning that you just described?
So the best way right now in order to determine, so we do have docs. If you go to rancher.com, there's a docs link. But to be perfectly honest, the best way to figure, so we have docs for Rancher, and so Rancher Compose over there. So the best way to kind of understand what can go in is to go through the UI and then do an export. So I've created that load balancer, and then I say view config, and then this will tell you basically exactly what has been set up. which is, so we have a load balancer, scale 1, here's the configuration, the load balancer config, the ports, everything is over here. So basically you can just copy and paste this whole thing into your file. That's really the best way to figure it out, but we also have documentation.
Thanks. And those docs are brand new too, so if you've been using Rancher for a while and struggling with using the bit of docs we've had in GitHub, we've just implemented this new doc system. It's hopefully will make it a lot easier to find what you're looking for. Is another big thing that's part of the beta release, was having all these new docs. So play with them. If you see something that's not working, they're all open source docs, so feel free to propose changes or make pull requests on the docs as well if you think something could be described better.
Yeah.
Okay.
Okay. So let me go through and let's see. Let's demo. So I can show you what we had, 81 to 80. I'm going to set up the load balancer here. So the simplest way, I'll show you kind of like the minimum configuration for a load balancer, because it's quite simple, is WordPress here. Okay. So you just need to say what's the public port and what's the private port that you're load balancing, and then what you're linking it to. So we have this WordPress image. And so you notice the ports here, I don't actually have that exposed out to the internet. So it's one of the nice things about our load balancer is it basically runs on our private network. So you don't have to, what you're load balancing doesn't actually have to be exposed out to the internet. It still stays private. So I'm going to go and let me delete. I'm going to delete the WordPress and load balancer and then redeploy them from this compose template. So when I do that, you should see these delete. Yeah, so WordPress and the load balancer. That one is still deleting. Okay. So let me bring this up. Bring this all up again. Man, it's actually a bummer that these aren't working right. I'll have to figure out why that's not working on Windows. Okay. Oops, I hit Control-C too early. Let's bring that up. Oh, you can see the storage. It's pulling again because it basically deployed to a different server. So it'll take a second. But so I want to show, basically, so as you scale up, so one of the great things about our load balancer, since it's tied to the service, as you scale up the services, it adds it to the load balancer. So let me bring this up again. So bringing up the load balancer.
Darren, while you're doing that, just a couple questions that came in. I figured Carlos had asked us earlier, and I hadn't had a chance to respond. He was just asking about the scale that Rancher can handle. So he's developing an indie game that's massively multiplayer and persistent, and he wanted to know, could we deal with thousands of hosts? What kind of scale are we expecting Rancher to manage? I mean, obviously, I don't think, Carlos, you'd be using the UI if you start talking about thousands of hosts. You'd probably be using the UI, the script. But absolutely, Rancher's, definitely, we test it at scales that you're like what you're talking about, and from a host level, we don't see any significant limitation. I mean, there's no real limitation. Obviously, you'll need a bigger database, but otherwise, there's no limitation on the size that's inherent to what Rancher can do. There was another question, and Darren, I'll let you kind of maybe you want to talk about this, but Cole Brumley asked about data and the data layer, and it is a common question as people get using containers and starting to deploy this. Is what are we working on with regards to the data layers? Can volumes only be backed up, or can they be moved, duplicated, etc. in this version? What have we got right now? What's coming as far as storage management capabilities in Rancher?
Oh yeah, so quite a bit really is coming there. So what you'll first show up. So we already have this integrated with the Docker. What they're doing now, Docker 1.7 is being released, but they've kind of created this experimental branch. So if you compile Docker 1.7 in the experimental mode, you get volume drivers. And so what we have running, and if you're coming to DockerCon, we'll show you this. We're demoing it at DockerCon. Is basically you can go and create a container and say the volume driver is Rancher, and then we create a a persistent volume for you that you can then snapshot, and it'll be backed up to S3. So you can just run a command line, to create a cron job or something like that to just, snapshot that volume, and then it'll incrementally get backed up to S3. So that's what we're initially kind of putting out there, and so that's really soon. But then we have some more work on actually doing live mirrored volumes. So, not only can it be backed up, snapshotted and backed up to S3, but it'll be live mirrored to another host.
Cool. And just on the storage topic, one of the questions was, will you be able to mount S3 storage into containers?
Well, no, not. I mean, so the thing is to mount an S3. I mean, that's there's like fuse drivers to do like S3FS, things like that. You can do something like that where if you had mounted it to the host, we can then just do a bind mount from the host, and then you'll have that S3 storage. Definitely someone can create a Docker volume driver for that, but we don't. I mean, like Rancher, we don't have like specific support for that, except for kind of what you can find from the community. So one of the nice things about Docker or Rancher is that we don't really try to abstract you too much from Docker. Like, we expose all the options, and so if you can find someone who's doing it with Docker, then it should work in Rancher too.
Yeah, and as far as the S3 piece goes, what we are doing with S3 and object stores in general is using them as a target for those backups. So as you create volumes and you want to set up, the backups Darren was just talking about, or restore points, you'll be able to do that, and obviously S3 would be the place you can deploy these to. One other question that came in that's sort of on the same topic. It had to do with sort of the IP addresses on the host. So when you're consuming the IP addresses, are those actually, does it document somewhere how you're creating, which IP addresses are consumed and what is available, and maybe how do we know how to schedule the container so that the IP addresses don't get into conflict?
So right now it's somewhat like hard-coded in Rancher that we use this 10.42/16 IP space. And this will change. We'll make it kind of a, so you can configure that subnet. But right now it's kind of stuck to that subnet. And so basically when we deploy containers, we use that subnet. So as long as you're not using that subnet on your host, you're fine. And then we just manage that IP space. Yeah, so I don't know if that directly answers the questions, but that's kind of all we really do for IP management is the IP addresses of our private network.
And then someone asked, could we replace our overlay network with Weave if you're using Weave or you're comfortable with Weave?
Yeah, so one of the great things that's come, as I said, Docker 1.7 is kind of laying the foundation for a lot of great things in terms of storage and networking. And so one of the things they've done is they've implemented a whole new networking model that should pop up in 1.8. And so we've worked and talked to the Weave guys a lot on integrating Weave with Rancher. We've kind of done some proof of concept things, but you'll see better integration coming kind of over the next 2 months as we start working on Docker 1.8. So it is definitely possible to use Weave. But we provide other services, like load balancing, service discovery through DNS, things like that. So it's hard to use those with Weave right now. But when, as I was talking about the next couple months, as we do the better, when we start working on the Docker 1.8 things, you'll see more first-class support for any Docker network driver. So it's definitely coming. Right now, you can get it working, but it'll be a much nicer integration in like the next 2 months.
Okay, so go for it, Darren. What are you going to show next?
Well, so I had set up this load balancer. So I actually have that running. Basically, you can see it running through the load balancer, and I just wanted to show. So basically, as I go and I scale up, so I can say scale WordPress 2. basically, so that's going to spin up another WordPress container, and then the load balancer will automatically start load balancing that. So basically, so I wanted to show you kind of how you could do an upgrade. Since I started with this WordPress, I'll just keep continuing with this. So if I go and I edit my Docker Compose, imagine I had a new version of WordPress. So I might call it WordPress, or I'm just going to stick with the same image, but I'll call it a new service. So I'll say it's WordPress 2. Okay, so I've added in this new version of WordPress. So if I go and I say up on WordPress 2, so this is going to go and create the WordPress instance that starts it up. I'll show you my graph view here because it demonstrates this a little better. View graph. Okay. So I've got my new WordPress version up and running, and there's one container. So I could if I wanted to, I could test that out individually. Just hit it. I can expose just expose a port. You can, if you want to, you can actually just I have this one instance running. I can actually just go and edit this one container here. Sorry, where's the edit box? I can edit this container if I wanted to, and I can actually just expose out this port dynamically. So I could expose it onto the host as some port, maybe test it out, make sure I'm happy with that version, before I actually make it live. So now that I have, I'm happy with my WordPress, new version of WordPress, then basically what I can do is now I'll just go and edit my Docker Compose, and I'm going to link this in. So now at this point, I'm going to have two of these running. So I'm going to have the old version and the new version. So let's say I actually want to do like a rolling upgrade. So now if I go and I say Docker Compose up on the load balancer, since I just changed the link, so when I hit enter on this, I'm pretty sure the UI dynamically update. So now I've added that into the load balancer, and now it's in the load balancer. So now this will start taking traffic. So this is pretty much 2/3 of the traffic will go to the old one and the new one. Then I can start scaling up. So I can say scale up, scale WordPress here 2 to, let's say I want 3. Oops, sorry, I typed that way wrong. So now I can start scaling that up. So I can say, okay, now now I'm scaling up the new application. I want 3 of these. So that will start updating. And then as I'm scaling that one up to 3, then I can then go back to the old one, and maybe then I can start scaling down the old one. So that's scaling down the old one to 1, that one's scaling it up to 2, and then eventually I'm just going to want to remove it from my load balancer. So basically, we're just going to pull that out and then do an up again on the load balancer. So once we do that, let's see, did it update? Sorry, let's see. Oh yes, there you go. So it did update, and then it pulled it out of the old one. So, and then I'm happy with that. I have my new version. So then I'll just go and delete the old WordPress. So that's basically how you can do an update through the load balancer. That's so there's actually, if you have a more complicated application like some self-clustering systems and things like that, they actually don't want to go through a load balancer. You can do actually the same scenario with something we call a service alias. So because under the hood, the way we're doing all this service discovery is all based off of DNS. And so I can go and create, I'll show you here, I can go and create, let's say I wanted to call WordPress, I'm going to call it web. So I say the image is going to be the Rancher DNS service, and we're going to link this, we're going to link it to WordPress 2, which was the one we still have running. So when I do an up on this, let's Rancher Compose up on web. Okay. So what this has done is this has just created a new alias called web. To see this actually working, what I can do is I will just actually, let me do it through the UI. It's a little faster. I will actually just add a Ubuntu console here, and I'm going to link it. Oops, that twice. Link that to web as web. Give that just a second. Okay, so what I'm trying to show here is that basically you can create aliases for the your app, so WordPress too. So if I go into this, this Ubuntu console that I just launched, I should be able to then say, okay, give me a second. Hey, it's working. It's not really moving here. What's going on? Okay, sorry, it's just slow or something. Okay, so you can see when I said ping web, so what it's actually pinging is the MySQL instance. Or sorry, not the MySQL, sorry, the WordPress instance. So if I go back here, let me show you this. I think this is, I'm probably doing a bad job of explaining this. So Ubuntu is linked to web, which is then linked to WordPress too. So basically what this has done is it's done like kind of like almost like a DNS CNAME type thing. But basically we make web look like WordPress too. So the reason why you want to do this is we can actually spin up WordPress 3, WordPress 4, like new versions of the application, but always have it known under a consistent name. And so you can basically do the same thing that you do with load balancing, like the load balancer, how you can do the upgrade of deploying new applications, scale up new versions, scale down the old ones. But you can do that all through DNS. So if you have an application, this is for a lot of like more complicated applications that don't like to have an intermediate load balancer, you can actually do this all through DNS. So this is a little bit more of an advanced feature that we have.
So Darren, just to stop you for a minute, there's a lot of questions that come in while you've been talking, and I just want to kind of go through a couple of them and see if we can answer them. So one was from Omar Soba, and he asked if he has a bunch of containers linked together like we have shown here, can he query the Rancher API and get a list that would show all the containers that are in a group?
Yes, like so for a project or something like that. So basically, if you want to start exploring around the API, you can click on any one of these little circular boxes here, and they always say View an API. So you can see here, this we have a little bit of a confusing API naming. We're going to switch that very soon. But basically, you can see this is the WordPress project that I created here, WordPress. And then you can see all of the services associated with this. So this is the DB service, and then for each one of these services, you can see what are the instances associated with it, the containers. So this is all available through the API. The API, like it's extremely easy to use. If to learn how to use it, the best way is actually just to click around through this UI, because we show you the actual unexpected end event. I don't know what the heck that is, but let me show you. We show you the actual like API requests. Okay, you can see it here. Like here's the actual curl command you would run. There's the HTTP request. You can see that all if if you want to interact with our API. Yeah.
Is there a way to? So Omar's follow-up question was: is there a way to query the API and get the image or visual like we have with a group of containers, the like mapping? Is there a way to pull that from Rancher and have it export that?
Oh, this graph here?
Yeah.
Well, I mean, so the way you would basically have to generate this yourself. We don't actually have this in the API, but the information is there. So the UI, the way the UI works is it's actually just a completely static library, and then it is you launch like developer tools. Yeah. So basically, like as you click around in here, you can see it's making. Let me see if I can get it to make a request or something. Oh, so here it's basically the UI is making all the same API calls. So you can see this is actually our API. So it's like the UI is 100% driven by our API. So absolutely everything you see in the UI you can do through the API. There's a very clean distinction there, like because it's really the UI is just a static JavaScript library that's running in the browser.
Okay, and then another question that came in from Alex Kirkin. He was asking, is there a plan to support any of the service discovery tools like Console or Zookeeper, for example, as opposed to our own DNS-based service discovery? So, Alex, I can tell you, I can sort of answer that for you. I mean, we, we're sort of focused on implementing sort of a complete set, and we talked about this with networking on Weave and other things, but the design of Rancher is that these components are meant to be pluggable. We talked about it earlier with scheduling. So in the short term, we haven't made things like service discovery pluggable yet. You can certainly use them because they work great with Docker, and Rancher exposes Docker, so you could just use them directly with Docker as it is. But in terms of like swapping it out inside the project to say plug into Console or Zookeeper, we're not there yet. It is something we've talked about. Certainly, as an open source platform, it's one of the things that we are. We hope that we can get contributions from people that want to see things like that. So if it's a high priority to you and you really like Rancher but want it to work with something like Console, let us know, and we can also kind of guide you on how to make that happen. There's a couple questions from Kirti Raja. Hope I got that right. The first question was, is it possible to mount like a NetApp volume on a container VM? And so I think what he's asking is if I've got a VM that's got a NetApp volume attached to it, can I mount that volume to the container itself? Do you want to talk maybe a little bit about volume from and how to do that?
Yeah. So basically, I'm on the add service screen here. On volumes here, you can just basically add a volume, and so if I've mounted my NetApp to something like this, then you can mount it into your app. So the syntax for Docker is basically the path on the host to somewhere in the container. So I don't know, just var lib stuff. So basically, if you set up a bunch of hosts and you mounted that directory on all the hosts, then every container that deployed on one of those hosts would just automatically get your NetApp content into your container. So like one of the so as we've been showing WordPress, honestly, WordPress has like all of the content in it, like blog content or whatever. So there's some things that are in a database, but then there's like static files that are on the host. And so one of the common ways to run WordPress is actually through, some type of shared storage if you want to cluster it. And so you can actually, do that if you just have the shared storage available at a common location on all your hosts.
Just another question, kind of jumping backwards a little bit here too when we were talking about load balancing, but there's a question that Marco asked. He's saying if a host machine has multiple IP addresses, can we bind load balancers to specific IP addresses so we can have multiple load balancers exposed on the same port, say port 80, on different public IP addresses? Does that make sense? So the host machine has multiple IP addresses. Can you bind load balancers to specific IP addresses?
No, we don't actually have support for that right now. We will add that. So basically, when we expose out to the host, we just expose to a port. We don't give the option of a specific IP, but we should add that. That Docker supports it, but that's kind of something we're lacking today. So we should definitely add that. So that should be coming, and then additionally, you should be able to deploy one load balancer and then use the host name based routing. That's actually like the request we get a lot. So somebody wants to deploy one load balancer, but then have a different. You say for this host name go to this set of containers, for this host name go to that set of containers. That's the other thing that we're working on.
Yeah, one additional question from Kirtharaja was if you had two different customers, customer A has a Jenkins box and customer B has a Jenkins box, both on the same container, I think maybe both on the same host, how to point them to DNS of a public IP address. Hope I'm getting that right, Kirtharaja. I haven't struggled understanding what you're asking, but does that make sense to you, Darren?
So one of the things as we have is I'll show you. I'll show this here is so as I say, like each one of these services that we deploy, like so when I went to that Ubuntu console and I said ping web, it hit web, which is our DNS that we set up. We have this service here, which is just called external service, and so basically what we can do is just set up a DNS entry. It's called foo, and then you can have it set to any list of external IPs. So you can add as many IPs as you want. So when you create this service and link it, then basically all that basically is doing is setting up a DNS entry. And so I don't know if that might answer your question.
Okay. There's another question from Juan Ignacio Donoso, and he asked it a little while ago. Kirtharaja says it does answer his question. So good. Okay, back to Juan's question. He was asking about upgrade paths. How to make upgrade to stateful services. For example, if he has a MySQL service and he wants to do migration to a new version of that MySQL service, how do you add a new MySQL container that can be migrated without losing any records made in the first MySQL container? So, do you want to talk about sort of either database clustering or volume management or EBS?
Yeah, so I mean, upgrading stateful things then ends up being like often very specific to the application, how you're doing it. From the upgrade scenarios, we're kind of our first phase as we went into this beta is we wanted to make sure that we had like all the kind of various building blocks so that we could support people in doing these different upgrade scenarios. Like if you want to script it yourself. So we definitely don't have like kind of like an automated way of upgrading a stateful service, but we do have various things that you can do. And so let's say like this database is actually stateful. So one of the things you can do is if you wanted to create sorry, that was the wrong terminal. If you wanted to create a new version of your database, oops. You can basically say, you just say volumes from DB and DB2. So basically, what this is going to do is it's going to launch database 2 using the volumes of the database. Now, if this like in order for this to like actually work right now, you're going to have to shut down, like you're going to have to stop this service, start the new service, and it's using the volumes from that service. You can't run them in parallel since it's two databases hitting the same files, but that will allow you to upgrade the database. So if you want to do a completely seamless upgrade with no downtime, you really need to get into like clustering and replication and things like that for your database. But then that all becomes specific on how kind of the database works. But the key thing here is that basically with volumes and volumes from, you can point your service to the same, like you can deploy a new service that's using the data from an old service. And then once you have so I have this new DB running, then you can then get rid of the old database and deploy, as I said before, you can create like an alias. Because if people are, you can see this service here, WordPress is already linked to database, DB. So I can go and create a DNS service here, DNS service, and then say links to DB2. So basically what that will do is now it will create DB, like your new DB2 will be known as DB, and so anybody that's linked to DB will get that service now.
Cool. And then just expanding on that. So Michael asked, is there any thought given to something that does handle like stateful information like Flocker under the hood, or delivering some kind of persistent storage solution under the hood to enable persistent storage volume?
Right. So I mean, so basically, it's kind of a lot of coming soon. Is now that Docker is getting better support for volumes and volume management systems with the stuff that they've put into the experimental branch of 1.7. We'll be doing a lot of features around how to manage stateful applications, handle things like Flocker. It gets a little different because basically, like when you start looking at shared storage systems, just even that, which is easier to explain than just like say Flocker. Like with like a NetApp, you'll have some shared storage, but that shared storage is only mounted and available on certain hosts. So where is that storage available? So there's like more scheduling constraints. So it gets a little bit, more complicated on how to manage that. And so that's kind of like our next phase is really adding in a lot of these storage capabilities.
Yes, definitely. Okay. So coming soon is fine. It's beta after all. Thank you, Michael. That's true. Yeah. It is beta. So yeah, we're doing a lot on storage over the next 6 months. I think the first one is the snapshotting. The second one is some of the work we're doing on persistent storage. So okay, Darren, we're kind of running out of questions and time. Is there anything else you wanted to go through in the demo before we wrap up?
Yeah, the very last one was just health checks. We haven't talked about health checks at all, and so basically I can just show that really quickly, and hopefully in just like 5 minutes. And so let me show you if I go and I add a service. We'll just stick with the WordPress here, and we'll call this WordPress health. So basically in the advanced options here, you can do health checks, and so you just give it pretty much a port. So these are all just HTTP based health checks, and say index PHP. We'll have some threshold here. Yeah. So if this works properly, then that.
What are you setting up here? You're setting up a health check that's going to monitor the port 80 on this new WordPress environment?
Yeah, exactly. So we've launched this container, and we want it to hit port 80 on the container, this URL, index PHP, and basically it'll hit this every 2 seconds and make sure that it's good. If it's not good, then we will end up showing, we'll show basically some error. So we can, if you say like I want scale 3, and the health check goes bad on one of those, we'll get rid of the instance and deploy a new one. So let me start this up. I don't know if the connection, I'm having a connection problem here or something.
It could be the network. While you're doing that, there was a question that came in from Guangzhou, and he was asking, it kind of goes back to the storage stuff we've been talking about, but what does it look like for supporting container live migration right now? Is that something that we already deal with? Is it coming in the future? Is it coming in Docker? What's the best plan for if I need to move a container across hosts?
Right. So right now, your best bet is to do basically cold migration, which is shut it down and then move it over. And so what's coming with a lot of the storage functionality that we'll be working on, but also like with Flocker, is they support basically kind of like a cold migration, which is actually you have a container running, you replicate the storage, you shut it down, and then you start the container somewhere else. So cold migration is something like you'll see like within the next 6 months for Docker, but there is a lot of work that's being done for live migration. Live container, which is like the more lower level project inside of Docker, has just recently got support for this project called CRIU, which is Checkpoint Restore for Linux, which is kind of the way that they're going to do live migrations. So this technology, like live migrating a container, is really a little far off. You're probably not going to see it for about like a year, but it is being very actively worked on. But it is a little bit off.
There's another question that kind of is in the same, a little bit in the same vein. It was about DR snapshots. So, how will if I take a snapshot on a node, how will a DR snapshot work on node failure? He's thinking about Rancher VM where the host is running, the VM dies. But just in general, how do you envision snapshots working? And maybe we can start with that. And talk a little bit about recovery of nodes or recovery of services.
So how will contain the volume snapshots work? That's basically.
Yeah, exactly. Like how are you when if I've snapshotted a volume, for some reason the host fails, what am I able to recover to? I mean, what's the value of having a snapshot of a container volume? What am I able to recover from that? Is it?
Yeah. So basically, the snapshotting feature is mostly for DR right now. So basically, you will be able to snapshot a volume backed up to S3, and then you'll be able to deploy a container from any arbitrary snapshot, and that will then it'll just basically restore the volume from that snapshot, and then that can be restored to any host, not just the one that failed. So if you've taken snapshots of some container and that host goes down, then you'll be able to go and deploy a new container from some previous snapshot, on a different host.
Okay. Got it.
Okay. So this is kind of interesting. So right. So I deployed this with the health check, and if you're watching this, basically it's just cycling in a circle because I realized when I deployed it, I didn't actually link WordPress to a database, so it doesn't actually have a database. So you can see what happens is as this keeps cycling through, so the app comes up, so it's starting right now, and then you'll see a little bell icon because the health check fails, and then we bring it down. And then, so basically, because the health check on this application is always failing, it won't ever actually come up. So you can kind of see that that's working, but wasn't really kind of the.
What you want to show? So a couple questions. There was two that I wanted to hit on as we kind of get towards the end. One was from Richard, and it kind of gets to just the Rancher management server and its role. So Richard Silver was asking, he's curious about running multiple Rancher management servers. If a single Rancher server goes down, will I be able to have a second to manage my environment? So I'll take that one, Richard, while Darren's tinkering. The sort of default configuration of just deploying a single container with everything working inside of it is great for getting started, but it really doesn't address your issue. The answer isn't necessarily just running multiple Rancher servers. It's actually running like a clustered server or a clustered service. So the Rancher service clustering, you can do it today. There's docs and some information on how to do it, but we're actually doing a lot of work right now to make it really simple so that as you spin up Rancher, we basically use Compose to cluster our own management server layer, and you can scale it as big or little as you need it. And in that case, then, if the host goes down or the service goes down, you would still have it. The other thing, obviously, is the impact of a failure. If Rancher's management server is taken offline, there really is no impact to anything running, obviously. So it's an out of the data path platform, but also it's really designed so that that anything you can do while Rancher's, say Rancher's offline, you're able to come in and access a lot of that just by using Docker run. And so using Docker run directly on the machine, and when Rancher came back online, it would discover those changes and update itself and understand what had actually happened. So definitely recommend clustering, and I think it's the way to manage this if you start to go into any serious production deployments. But there's sort of two sides to that one. The other question was sort of it's kind of in the same line of migration, but is there any scheduling rules to move containers from one host to another? And scheduling doesn't deal with moving containers. Scheduling sort of deals with placement of containers. And as Darren was saying before, live migration of containers is still not really something that that Docker supports. So if you need to, more often than not, if you need to run something and move it, you're going to either stop it and deploy it again on another host, or what you can do is obviously schedule new ones. So if you have any kind of clustered application, you can just create a new version of that container from the same volume that you were deployed on somewhere else, and then incorporate it into your load balancer or expose it through DNS. So I hope that answers your question, Juan Ignacio. Last question on something like this. This kind of Renaud asked this question, and it goes to what you've been working on, Darren. But he was asking how does the Nginx web server handle WordPress permalinks? So usually a problem. Do you support an Apache web server with the Nginx used for front-end caching only? And I think that's referring to in the Rancher server, but I'm not sure. Do you want to try and take a hack at that one, Darren? And I mean, have you clarify it, Renaud?
I don't know if I totally understand that question. I mean, you can definitely, like with the WordPress example here, you can put an Nginx in front of it if you want, and then do do some, however you want to configure Nginx. But no, I don't think I quite understand that question.
Okay. Well, Renaud, if you want to elaborate on it further, we'll try to answer it. But otherwise, I think we're kind of coming up on 2 hours. So, Darren, unless there's anything else you want to show, I'll probably wrap us up.
Yeah. So, I mean, just I configured the WordPress one properly, so you can see basically when you click like scale up, when it's starting a new container, it goes into this initializing state because the WordPress is still starting. But then as our health checks will clear, it ends up going to green. Now, if I was to go and actually stop one of these things, because I've actually said, like, I want 3 of these, I've set the scale to 3. So basically, we've stopped it so it's in a degraded state. And then within about 15 seconds or so, we'll end up detecting that that container is down, and then we'll start up another one. In this situation, we can actually just start that one. If it was in an error state, then we would actually delete it and deploy a new one. So that's basically, based off of the health checks, we'll determine if the app's healthy and then deploy new ones.
Great. Well, let me just take back control. I'm going to take it back and wrap us up a little bit here. So thank you, everyone, for attending today's sessions. If you want to get started using Rancher and don't already have an environment set up, you can go to our GitHub page. This is everything we've showed is open source. Rancher is open source. Rancher OS is open source, which we talked about a little bit today. Didn't really show much of. But you're welcome to get in and play with any of this and try it out. We're always looking for contributors, people to file issues, to